Hey Team Bio, welcome to your screencast on Introduction to Organic Compounds. I first want to say, please watch this for homework, but also remember to finish your HHS CAP script because you're going to come into class next period and you are going to do a live take of your script. And you're going to time yourself and figure out if you need to add a little more or cut a little bit and talk with your partners about the total length of your screencast because it cannot exceed 10 minutes. Okay, that being said, back to business. This is your introduction to organic compounds. So we're jumping around here. We started the year kind of talking about the process of science and some of the big ideas in biology. What does it mean to be alive? What is evolution? What are the biggest and smallest things in the world, going down all the way to atoms and then building up to biomes. And then we did a deep dive into ecology. And now we're going to step away from ecology and climate science, and we're going to dive back down into the smallest things that make up living systems. So we're going to start a new unit on biochemistry. Okay, which brings me to our first idea in biochemistry, and that is this idea of organic compounds. Well, what is an organic compound? It's not your grocery store definition. So an organic compound is going to contain, there's an I in here. Organic means that something contains carbon-carbon, carbon-carbon, or carbon-hydrogen bonds. Our first definition, our simplified definition of organic was contains carbon, but to get a little bit more nuanced with it, it's actually that an organic compound is going to contain carbon-carbon or carbon-hydrogen bonds. So, for example, an inorganic compound would be H2O or water. Water has hydrogen in it, but it has no carbon and has no carbon-carbon or carbon-hydrogen bonds. Another example of an inorganic compound would be CO2. Carbon dioxide contains carbon, but does not contain any carbon-carbon or carbon-hydrogen bonds, so it is also inorganic. Some examples of organic compounds. Are methane, CH4, which looks like this. And I'm not going to draw this out, but glucose is, oops, not a G, C6H12O6. We will build glucose later in the year. Okay, so that's what we mean by something that's an organic compound. It's going to contain carbon-carbon or carbon-hydrogen bonds. Oh, and I guess I should also define a compound is chemically bonding two or more elements. So, for example, O2, molecular oxygen, which looks like this. This would be an example of a molecule, but it is not a compound because it only contains one element. So an organic compound contains carbon-carbon bonds or carbon-hydrogen bonds, and it's going to chemically bond two or more elements together. Okay, why are we talking about organic compounds? Well, when we look at living things, we can look at consumers. We can look at decomposers. We can look at producers. And we find that they are all composed of the same organic compounds. So you might think, oh, this mouse is very different from this fungus, which is very different from this raspberry bush. But if we dive into the structures of all of these living things, we'd find that they share the same or many of the same organic compounds. Okay, carbon. Here is, oops, gotta finish this up. Here is a model of a carbon atom. What makes carbon carbon? Well, within the nucleus, we have protons and neutrons. And carbon atom always has 6 protons. If it is uncharged, it has 6 electrons, and it usually has 6 neutrons. We're going to talk about this in the next screencast, what happens when you add or subtract neutrons. We're actually going to be talking about what happens if you change all of these things. But a carbon atom, uncharged carbon atom, 6 electrons, 6 protons, and usually 6 neutrons. And notice that the carbon atom, we've got here these different shells of that the electrons are occupying orbitals, which are kind of areas that we can predict that we'll find the electrons in. They're not actually shells like this. They're more clouds that represent areas of probability in which we might find an electron. Anyway, that's not super important. What I want to talk about here is the different shells of this carbon atom. The inner shell is composed of 2 electrons and it is full. The outer shell is composed of 4 valence electrons and it is not full. A full outer shell is 8 electrons. So as a result, in order to capture or to get 4 more electrons in this outer shell, carbon needs to make 4 bonds. And this is why carbon is such a great atom to build organic compounds with, because it wants to form 4 bonds. Oops, I meant to highlight that, not circle it. We can form many complex structures. Including long branch chains, and rings. Okay, so this is why carbon is such a fantastic atom to build complex molecules with, because it can form 4 bonds. And that is the result of 4 valence electrons in its outer shell and the need to have 8 in order to complete the outer shell. Okay, so what do we use carbon to build? Well, the big 4 organic compounds are as follows. We have carbohydrates. We have fats and lipids. We have proteins. And we have nucleic acids. Oops. Okay, so you probably have heard these words before: carbohydrates or carbs, fats and lipids. You might have not heard the word lipids before, but you've definitely heard the word fats. I'm sure you've heard the word proteins, and nucleic acids you might not recognize, but know that DNA and RNA fall under this category. So these are the big 4 organic compounds, because when we look at living things, no matter what category, notice that I've only picked examples of eukaryotic cells, but I could also have prokaryotic cells up here, and they would also be made of the same big four organic compounds. So we're going to do a deep dive into what are the structures and functions of each of these four different classes of organic compounds. All of these organic compounds, something that they have in common is that when we look at how they are built, we've come up with kind of an organizational scheme for talking about the most simple form of these things to the most complicated form. So the most simple form of any of these different organic compounds is called a monomer. A monomer is one basic building block. You can kind of think of it as like one Lego piece. If we take two monomers and we covalently bond them, we get what's called a dimer. Di meaning two, mers, I don't know what mers means, thanks. So a dimer is going to be two building blocks. That are covalently bonded. So two monomers covalently bonded is a dimer, and then a polymer, or polymer, is three or more. Oh, I guess I could think of this as like two Lego pieces stuck together. Three or more building blocks. And you can kind of think of this maybe as like a Lego castle. This is a complicated structure. Okay, so all of these big four organic compounds have monomers, dimers, and polymers. And we're going to be discussing in much greater detail in screencasts to come what the monomers, dimers, and polymers of these big four organic compounds are. Okay, that is all for your introduction to organic compounds. Reminder to complete your script if you have not done so already.